Jan Ozer here. Welcome. Thank you for coming to this Distributing to Desktops and Mobile Devices via HTML5 webinar. Got a couple of announcements. Let's start there. I think this presentation is going to be a little bit quicker than some of the others. I'm thinking about 15 minutes. Video, as you're watching hopefully now, and handouts are available on the page you're watching from. You can ask any questions via the comments function on the web page on Streaming Learning Center. And if you want to tweet about this, please use the hashtag HTML5 Flash and then include my name in it so I can find it easily. I thought that we were going to be using the new Brightcove live streaming service for this webinar, but I've had a pretty horrible morning, including a hard disk crash on my primary encoding computer, and I just couldn't pull it together. So we're looking at this on YouTube Live, which is the service I've used, I guess, one other webinar. You're hopefully watching it on my homepage, and if you want to click over to the YouTube player, you can leave comments there. So you can either leave comments on the YouTube page, or you can leave comments on the Streaming Learning Center page. Let me get there right now so I can make sure there's nothing blowing up on me. And nothing else blowing up on me. Okay, any issues, let me know. I'm watching or monitoring the page on the Streaming Learning Center, so if you have any comments, any issues, leave word there. As always, most of the information from this webinar is from this book. If you have any questions, the book is available on Amazon.com. And okay, a little bump in the road there. Let me make sure we're up and running in okay. Okay, I'm going to assume we're up and running. There's a 45-second delay with YouTube that makes it kind of tough, but I'm just going to go ahead and keep going. So okay, so here's our agenda. We'll start out talking about what HTML5 is and how it works, and then we'll look at the current market share of HTML5 compatible browsers. That'll tell us how many browsers out there can use HTML5 for video playback, and what codec they need to use what codec you need to use to produce an experience with HTML5 playback and Flash fallback. And then we'll look at when HTML5 just doesn't work for you. There are some serious limitations in HTML5 you need to know about before you decide that's the thing for you, and we'll cover that last. That will lead us into the next webinar. Which will be in a couple weeks. Okay, so let's start with looking at HTML5. What's the key benefit for HTML5? Basically, the premise of HTML5 was you would no longer need plugins like Flash. HTML5 became good, and it's still, as we'll see, Flash is pretty essential to most streaming producers. What HTML5 can do is, instead of obtaining the you're using, and pretty critical to understand that the browser has to supply the player and the browser has to supply all playback functionality, and we'll talk about why that's significant in a few minutes. Okay, so for the video tag to work, and the video tag is what replaced the plugin, and we'll look at what a video tag looks like in a moment. The browser must be, first, it's got to be HTML5 compatible. Second, it's got to play the codec that you use to compress the video that you're sending the browser. There's two key markets we're concerned about. desktop and mobile. We'll cover those right now. So if you cut over today and said, I'm not going to use Flash anymore, I'm just going to use HTML5, no Flash fallback, how many people couldn't watch your videos? Well, I ran these numbers this morning. The website that you want to use for this type of analysis is a website called Net Market Share, and just checking for any comments to see if we're blowing up here. Okay. So what I did with Net Market Share is I grabbed the top 10 browsers as measured by Net Market Share, and there's a URL on that page that you can see. And of the top 10 browsers, Internet Explorer still dominates, and Internet Explorer didn't become HTML5 compatible until version 9. So version 8, version 7, and version 6 combined to about 72.35%, which means, I'm sorry, they combine to about 27.65%, which means that 72% are HTML5 compatible. So again, if you decided not going to use Flash anymore, no Flash fallback, going straight HTML5, then 27% of the potential viewers out there couldn't view your video streams. Now, these are pretty much all older computers, and most people update their browsers pretty frequently, and I think Firefox and Chrome have done really well with a lot of younger and a lot of people who try new things. So you have to assume that a lot of these older browsers are in government and corporate computers where they just can't upgrade without getting permission from the IT department, and also with maybe older users who don't upgrade just because there's a new program available. So they may not be the target market that you're serving, but be that as it may, if you don't serve them somehow, and the somehow is going to be Flash fallback, then you're not going to be able to send video to them. They're not going to be able to view it via HTML5. The other thing about Flash fallback is it doesn't cost you anything. So, and we'll talk more about that in a second. Okay, so step number one, as I said, was what percentage browsers out there are HTML5 compatible? We see about 73%. Second question is, what codecs do they play back? And a codec is a video compression technology. There's two HTML5 compatible codecs that matter at this point. There's WebM, and then there's H.264. So H.264 is playable by IE, Internet Explorer 9 and 10, Safari, and Chrome, which means that Firefox and Opera will not play H.264. WebM, which is the browser that Google bought, I guess in 2010 to 2011, and then releases an open source codec, that will play back in both Firefox and Opera, but will not play back in Safari and Internet Explorer without a plugin. It will, of course, play back in Chrome. So Chrome is kind of the universal browser when it comes to HTML5 codec support. Back in January of 2011, Google said they were going to remove H.264 from Chrome. They never did. I think they'd be silly to do it, and I'm guessing at this point they never will. But as it stands today, Chrome plays both WebM and H.264 without any plugins. So conclusion number 2 is that if you want maximum HTML5 compatibility, you're going to have to encode to both H.264 and WebM. Okay? Now, what about on the mobile side? The good news with mobile is that there's virtually every smartphone, every tablet out there is HTML5 compatible, and they play H.264 video. So if you deliver H.264 video with the HTML5 tag, you're going to play on most smartphones, you're going to play on most tablets. And when I say most, I mean pretty much any tablet that's very, very new, that's in the last 2 or 3 years. Will play on the iPad 1. I have that I've tested. Will play on the iPad 2. I know that as well. So you've got pretty good coverage of most of the recent smartphones and tablets out there. And we're gonna run our own little test in a few minutes. Okay, so what do you have to do to implement HTML5? You've got to either encode to H.264 and WebM. Some producers don't do WebM at first. They just rely on Flash fallback for Firefox and for Opera. So when revision 3 came out and said we're going HTML5 2 or 3 years ago, they went HTML5 primarily, or that was the primary playback engine that they used, but they also supplied Flash Fallback. And when they went HTML5, they only supplied the H.264 codec. Now, I think in the last 6 to 12 months, they started supplying the WebM codec as well. But a lot of producers who go HTML5 are going HTML5 with the H.264 codec only, because that will play on mobile, and they can use Flash Fallback for the rest. So you don't have to supply WebM and H.264, but that's considered best practice, and as we'll see, Squeeze makes that very, very easy to do. Okay, if you're producing H.264 for HTML5, a couple things to know. It's H.264 only, not the MPEG-4 codec. You can use any profile you'd like. You can use any audio compression technology you'd like. The container format that I recommend is the MP4 container format. And that will give you universal playback. If you use MOV or F4V, the HTML5 compatible browser may call a plugin. So if you use an H.264 encoded file with an MOV extension, the browser may call the QuickTime player, which isn't terrible, but it's not what you want. You want it to play back natively in the HTML5 player, and for that, use the MP4 extension for the H.264 codec. And if you do that, that'll play both in, that file will play in Flash, it'll play in HTML5, and it'll play in mobile. So what is Flash Fallback? In the HTML sequence, so obviously every web page is going to have an HTML sequence in it. In the language itself, we're going to see the video tag, and that's going to be first. And then if the browser doesn't understand the video tag, the next clump of text will be for Flash Fallback. And let's take a look and see what that looks like. And that's here. Jump to a little bit bigger screen. And now's a good time to point out that you can, if you didn't get a copy of the handout in the email that I sent, you can download a copy from the page on my website that I sent you to. If you're having issues with it, then send me an email and I'll send a copy to you, but you should either have it or you should be able to download it from my website. And so this is what the HTML looks like as produced by Sorenson Squeeze, and we'll get there in a second. So the video tag is first, and the video tag first calls the H.264 file, basically saying, hey, browser, can you play H.264 video natively? If so, then it's done. It just hands off the file, and the browser starts playing. The next is the WebM file. If you can't play the H.264 file, well, can you play WebM? If so, everything's good, and playback starts. If neither of those codecs play in HTML5, then the next, as I said, clump of language causes Flash playback. So you've got H.264, then WebM, then Flash. And that gives you both support for every HTML5 browser out there, or HTML5 compatible browser, and it gives you support for legacy browsers that don't incorporate HTML5 playback. If you only encode an H.264 file and not a WebM file, Flash Fallback will also give you playback in Safari, in Firefox and in Opera. Okay, so how do you do this? How do you implement HTML5 with Flash Fallback? You can absolutely hand code the HTML yourself. You can produce the files using command line tools, using any encoder that you'd like, or you can use Sorenson Squeeze 9, which we're going to look at in a second. Now this is, Sorenson is not sponsoring this. They did help out by mailing their user base that this event was occurring, but I decided to have this webinar because I thought that HTML5, it's a great solution for people trying to reach a bunch of different viewers on computers and smartphones with in a very simple and inexpensive way. So much so that I did an article and a tutorial on it that's front page now at the streaming media site. So if you want to see a tutorial on this subject, you can go to streaming media. There's a URL that you can use right there, and you can see what I'm talking about. But again, Squeeze is not paying me to say this, or Sorenson's not paying me to say this, but I thought the solution was so elegant that I wanted to kind of feature it in this seminar about HTML5 and Flash Fallback. So how do you do it? Let me go to full screen again, and let me go over to Sorenson Squeeze, which is showing here, and this is the file loading area. These are the presets area, and as you see, there are two presets. There's a preset for 360, or both are 360p or 640 by 360. One is about 424K, one is 768K. You apply that by dragging it down into the settings window here, then you press the squeeze button to get the encoding going. If you look at the preset itself, you can double click it to load it into the editing window. And here's what Squeeze is doing. You've got the WebM codec here, that's first. I'm sorry, the MPEG-4 codec is first, the WebM codec is second. Squeeze supports multiple flavors of H.264, so you can encode with both the main concept and the X.264 codec. Here's the VPA codec. Squeeze consistently applies parameters like video data rate, audio data rate, and then the height and width here, so that you get a consistent experience, but you can customize the codec settings for both H.264 and WebM as much as you'd like. So basically, if you want to keep this simple, you just drag down the preset into the settings window, adjust the parameters as you'd like, press squeeze, and then Squeeze encodes the file. What it produces is the files that we see here. So we've got a JPEG image, we've got HTML, we've got the MP4 file, which is used for both Flash playback and HTML5 playback, and then we've got the WebM file here. If we open the HTML5 or the HTML file, let's do that in text edit. Did I get the wrong file? No? Okay, not my day, as I said. Let's try this. Okay, this may take a moment because Dreamweaver is a pretty big program, but hopefully we'll get a look at the HTML code. Okay, and here's the HTML code, and it looks surprisingly like the code that we looked at a couple of slides ago, where we have the video tag up here, we've got the MP4 file here, we've got the WebM file here, and we've got Flash Fallback down here. Okay, so basically the code that we're seeing is the same code that we saw here. Okay, and again, Squeeze is creating all this automatically. Basically, once you encode the file, it's producing the WebM file, it's producing the H.264 file, and it's producing the necessary HTML code to paste into your browser to get the file up on your website. Okay, so here's you can try this at home segment of the video. You can try the file. It's available at bit.ly HTML5_Watley. It's a very short video, about 9 seconds long. If you'd like, you can't monitor this, can't really see you out there, but if you want to play the file on any computer or any device and then tweet the results, just include the hashtag HTML5 Flash so I can find it pretty easily. My name would also be nice, and then include the platform and the results in your tweet. So, something like the file played fine on my iPhone 5 would be pretty good information. If you have a failure, that would be good information to get back to Sorenson. A couple of caveats: no solution is 100% effective, and also my website, the deseo.com address, is not optimized for streaming. So there's going, if a lot of people hit this at once, there could be some slow loading. but hopefully the file will play back. In my own tests, I tested 6 or 7 or 8 or 9 different playback scenarios. The primary ones are documented here. It played fine on my Android Toshiba Thrive. Couldn't really tell whether it played back in HTML5 or Flash because Flash is loaded on that version of Android. Played back fine on my iPad and iPhone. We know that was HTML5. Played back fine in IE10 using the H.264 codec. Google Chrome played back with the H.264 codec as well. And Firefox played the WebM codec. So those are the results I got. And we'll see if we get any tweets that talk about the results that you guys got. Okay, so I guess to summarize, HTML5 with Flash Fallback is pretty wonderful. I think for small to medium-sized sites who just want the video to play everywhere, but don't need some pretty important features in their video that a lot of larger websites do need. And that would include no true streaming. So HTML5 as it stands today doesn't stream. Every file is delivered via progressive download. If you're delivering hundreds of thousands of files, that can get pretty expensive because progressive download is much less efficient than streaming. So if one of the limitations of HTML5 as it stands today is no true streaming. There's no live streaming, so you couldn't do what we're doing right now via HTML5. There's no adaptive streaming. We are adaptive streaming today. YouTube is taking the signal that I'm sending it from Telestream Wirecast, which is the program I'm using. I'm sending a single 2.5 megabyte per second stream. YouTube is re-encoding that into multiple iterations for both mobile and for desktop. That's called adaptive streaming, one file in, multiple files out, and it gives you good coverage. So if you're watching on an iPhone with low bandwidth, you can get a decent image. If you're watching on a big TV with broadband connection, you should get a very, very high quality image. And that's what adaptive streaming does. It's not available in HTML5. There's incomplete closed captioning. Closed captioning is supported on a couple of HTML5 browsers, but not all of them. And there's no digital rights management. So if you want to protect your video, you can't do that via HTML5. And looking, a quick preview into the next webinar, which is going to take place in a couple weeks. I may move it up because I do need to test the Brightcove solution, and it may be next. It's currently scheduled for a week from this upcoming Tuesday. I may move it up to get another webinar for testing. These will be the first couple of slides in that webinar. What are these advanced technologies that I'm talking about? These are technologies that enable features like live, adaptive, real streaming, closed captioning, and DRM. What are they? Or who are they? Flash can do all this for you. HTTP live streaming, an Apple technology can do it for you. Smooth streaming, a Microsoft technology, kind of on the way out, but it's still being used by a bunch of different vendors and a bunch of different applications. And then Dash is dynamic adaptive streaming over HTML. That's an upcoming HTML5 standard that's slowly working its way into wide stream adoption, but it's not quite there yet. So we see on the left, Five does none of these except for captioning, and that's incomplete. These advanced technologies can give you all of these. So again, HTML5 is wonderful for HTML5 is wonderful with Flash Fallback for simple playback of shorter video files in a situation where it's relatively low volume, so you don't care about efficiency. But if your needs go beyond that, you're going to have to look at an advanced technology. And we're going to be talking about that, as I said, currently scheduled for October. Okay, we've got somebody. Let me go to the YouTube site. Okay, so I guess we're about 25 minutes into this. You've seen the details for the next webinar. Sorry about the roughness of the start. It's really not been a good day. Thanks for your attention today. I hope you find this useful. This webinar will immediately be available for on-demand viewing. if you want to catch it again, or if you want to send a link to any of the any friends or colleagues. Thank you for watching, and see you next time.